Physicists shockingly revealed the universe isn't real. Hold on to your seats because physicists have just dropped a bombshell. The universe as we know it may not be confirmed. In a shocking revelation that challenges our perception of reality, this discovery could change everything we thought we knew about the cosmos. Are you ready to have your mind blown? Quantum entanglement is one of the most mind-bending phenomena in physics, and its implications for our understanding of the universe are still being explored. Simply put, quantum entanglement is a state in which two particles become linked so that their properties are correlated regardless of the distance between them. The concept of quantum entanglement was introduced in 1935 by Albert Einstein, Boris Podolsky, and Nathan Rosen in their famous EPR paper. The paper argued that quantum mechanics could not be a complete theory of the physical world because it allowed for spooky action at a distance. Essentially, they believed that if two particles were entangled and one was observed, the other would instantly know what had been observed, regardless of the distance between them. Over the years, scientists have conducted numerous experiments to test this theory, and the results have been astounding. One such experiment was conducted in 2017 by a team of researchers at the University of Basel in Switzerland. They entangled two diamonds separated by almost a kilometer and found that they remained entangled even at that distance. It has also been used in the development of quantum computing, a field that has the potential to revolutionize computing as we know it. In a traditional computer, information is stored in bits, either 0 or 1. But in a quantum computer, information is stored in qubits, which can exist in a superposition of both 0 and 1 simultaneously. This means that a quantum computer can perform specific calculations much faster than a traditional computer, which has significant implications for cryptography and artificial intelligence fields. However, the most fascinating aspect of quantum entanglement is how it challenges our understanding of the universe. According to classical physics, objects exist independently of one another, and their properties are determined by their interactions with the environment. According to quantum entanglement, objects are intimately connected in the quantum world, and their properties are inextricably linked. This means that observing a particle can affect its behavior, and one particle's behavior can affect another's behavior, even if they're separated by vast distances. The implications of this are profound. It suggests that the universe may not be as deterministic as we once thought, and that observing it can change its very nature. Deterministic means believing that everything that happens must happen as it does and could not have happened any other way, or relating to this belief. It also raises questions about the nature of reality itself and whether it's fundamentally subjective or objective. Do you know anything about simulation hypothesis? It's the idea that our reality is not objective, but a simulated world created by an advanced civilization. This concept has gained traction in recent years and has been the subject of much debate and speculation in the scientific and philosophical communities. This concept is based on the idea that if an advanced civilization were to develop the technology to create highly realistic simulations of entire universes, they would be able to create many such simulations. As a result, the number of simulated universes would vastly outnumber the number of real universes. Therefore, the likelihood of our universe being a simulation rather than a real one is higher. One strong argument in favor of the simulation hypothesis is the rapid advancement of technology. We've already witnessed significant progress in virtual reality technology, and it's not difficult to imagine that we could one day create simulations that are indistinguishable from reality. In fact, some experts believe that we could be living in a simulated reality right now and not even realize it. Another argument favoring the simulation hypothesis is that our universe appears to be highly ordered and follows a set of mathematical rules. This has led some to speculate that our reality is a computer program running on some advanced civilization's computer. However, there are also many arguments against the simulation hypothesis. One of the main arguments is that creating such a highly realistic simulation would require immense computing power and resources even for an advanced civilization. It's still being determined whether any civilization can create such a simulation. Apart from these theories, there is currently no concrete evidence to support the simulation hypothesis. While some argue that anomalies in the laws of physics or the behavior of particles suggest that our reality is a simulation, these anomalies can also be explained by other theories. Despite the lack of concrete evidence, the simulation hypothesis intrigues and captivates many people. It raises fundamental questions about the nature of reality and our place in the universe. Even if the hypothesis is ultimately proven false, the exploration and debate surrounding it can lead to new insights and discoveries about the nature of the universe. Recently, a new theory of reality has emerged that challenges our traditional understanding of the universe. The study of reality has been a subject of fascination for centuries. This new theory, known as the holofractal theory, suggests that reality is fundamentally fractal and holographic in nature. It claims that the universe is not made up of separate parts, but a single, interconnected whole. This means everything in the universe is connected and interdependent, with each piece reflecting the whole. In other words, the universe is a fractal, with each part containing a smaller version of the whole. The holographic aspect of the theory suggests that the universe is like a hologram, where every part of the whole contains information about the entire system. This means that the universe is not just a physical system, but also an informational one. One of the fundamental tenets of the holofractal theory is that space is not empty, but filled with a fractal energy pattern. This energy, often called the zero-point field, is a basis of all matter in the universe. The holofractal theory also suggests that consciousness plays a fundamental role in the universe. According to the idea, consciousness is not just a byproduct of brain activity, but rather is an essential aspect of the universe itself. This means that consciousness is not limited to individual beings, but is a universal consciousness that permeates everything. While the holofractal theory is still relatively new and is yet to be widely accepted in the scientific community, there's evidence to support its claims. Recent studies have shown that the universe may be fractal due to the patterns and structures repeating themselves on different scales. On top of that, studies on near-death experiences and psychedelic substances have shown that consciousness may be able to exist independently of the physical body. Critics say that the idea is too abstract and lacks testable predictions that experimental data can confirm or refute. Now we will discuss the most complex and mysterious phenomena in the universe. And you guessed it right, we're going to dive deeper into the whereabouts of consciousness. Consciousness is a fascinating and elusive phenomenon that has captured the attention of scientists and philosophers for centuries. While it is traditionally viewed as a property of individual organisms, some scientists and philosophers have proposed that consciousness may have a broader role in the universe. One theory is the idea of panpsychism, which suggests that consciousness is a fundamental property of the universe, present in all matter, as we discussed earlier. This means that even subatomic particles may have some level of consciousness. The concept of panpsychism dates to ancient Greece. Some proponents of panpsychism argued that it offers a solution to the so-called hard problem of consciousness, which asks how subjective experience can arise from physical processes. One argument favoring panpsychism is that it can provide more unified and comprehensive views of the universe. Consciousness is not just the sole property of individual organisms, but is present in everything from rocks to galaxies. This means that everything in the universe is interconnected through a fundamental aspect of consciousness. While panpsychism is still controversial, some scientists and philosophers are exploring the implications of a universe where consciousness is a fundamental property. For example, if consciousness is present in all matter, it raises questions about the ethical treatment of non-human organisms and even inanimate objects. Another idea related to consciousness and the universe is the simulation hypothesis, which suggests that our universe may be a computer simulation created by a more advanced civilization that we just described earlier. It may sound like science fiction, but some have argued that it is a plausible explanation for certain phenomena, such as the apparent fine-tuning of physical constants that allow life to exist. If the simulation hypothesis is true, it raises interesting questions about the nature of consciousness in the simulated universe. If consciousness is present in the simulation, does it have the same properties and limitations as in the real universe? Would it be possible for conscious beings in the simulation to interact with beings in the real universe? Panpsychism and the simulation hypothesis may seem far-fetched, but they highlight the mystery and complexity of consciousness and its role in the universe. Thank you for watching. If you enjoyed this video, please make sure to like and subscribe for more content like this.